Hi, this is part 2 of the Project 1 video. So we're going to be doing example 3 on 2.1, which is matrix operations. So we have A is a 2x2 matrix, and B is a 2x3 matrix. We're going to find A times B. So the way I do this personally, I break it up into B1, B minus 3 and 2. And B2 will be 1 and minus 6. And then B3 will be 2 and 4. 2 and 4. So it's the same as 1.8, where we do kind of this multiplication. We just have one less row. But then at the end, we have all of our 2x1 matrices. We should have 3 of them. We just put them together because A is a 2x2 and B is a 2x3. So the first number from that is 2 from A, and the second one from B is 3. So the resulting matrix AB will be 2x3. So A B1 equals minus 3 times 2 will be 6. B minus 6, sorry. Then 1 times 2 plus 2. And then it'd be 4 times minus 3. B minus 12. And then minus 3 times 2 is minus 6. So this equals minus 6 plus 2 is minus 4. Minus 12 minus 6 is minus 18. So this is column 1 of AB. So over here we'll do AB equals, we'll go ahead and fill it in as we get here. Minus 4 minus 18, that's column 1. So A times B2, A times B2 would be 2 times 1, so now we're done with this B1, so we're on B2. So be 2 times 1, be 2, and then 1 times minus 6, be minus 6. We do 4 times 1, be 4, minus 3 times minus 6, be plus 18. So that equals 2 minus 6 is minus 4, and then 4 plus 18 is 22. So A times B2 is minus 4, 22. So go ahead and fill that in over here for our second column of AB. So be minus 4 and 22. So now A B3 equals this guy, 2 times 2, which is 4, and then 1 times 4 is also 4, 4 plus 4, and then 4 times 2 will be 6, no, I'm sorry, it's on the right part. 4 times 2 is 8, plus 4 times negative 3 will be minus 12. The resulting thing for this will be 4 plus 4 is 8. 8 minus 12 is minus 4. So the last column of AB will be 8 minus 4. So there's that. So for 2.8, after we finished example 1.2, I said we'd be coming back to this matrix, so I went ahead and wrote that down here, right here. So they should be the exact same, and they are. This is good. I mean, we did 1.2 correctly. So this is subspace. So we're finding the column, the basis for the column space of this initial matrix. So the way I set so the column space actually is fairly easy. What we do to find that is to find all the pivots. So it'll be 3 minus 14 and minus 3. So we'll go right here. This is the basis of column space of, we'll call this matrix A. This matrix equals A. Basis of the column space of A equals, so by this little guy right here. Then we do each of these little columns. So since we have 3 pivots here, we know there's 5 variables. Since we have 5 columns, x1 is basic. So we'll go back to the initial matrix and copy this down. So it'll be 3, 6, minus 6, and 9. 3, 6, minus 6, 9. So this is x1. Since we know that it is a basic variable, we'll write it down. So we'll do a comma. The other variable that we know is 3, since x2 is free, since we don't have a pivot for x2. We'll go ahead and copy down the third column. It'll be 6 minus 2, 6 minus 2, 16, and 4. Close this guy off. And then the last variable that we know is basic is x4. So we have a pivot for x4. So we'll write down the 4th column from the original matrix. It'll be 3, 1, 4, 1. 3, 1, 4, 1. Close it off with this guy. So this is the basis of the column space of A. Fairly easy. Null space is where it gets a bit more tricky, I guess you could say. So to begin finding a null space of A, I guess, you write this down. You parameterize. It. I don't know. You do that thing to it. So x1, I went ahead and wrote this out. So it'd be 3x1 minus 2x2 plus 3x3 plus 3x4 plus 3x5. And this is the parameterized version of this matrix. So x2, since we know it's free, we'll just write x2 right here. x3, since we know it's this guy right here, we'll do minus 14 minus 14x3 minus 5x2 minus 5x1. I did that backwards. I apologize. So instead of x2, this will be x4, since it's in the 4th column, and then minus 5x5, since it's in the 5th column. So then for x4, we know it's this guy. We know it's not free, since we have this minus 3 as a pivot in that column. So we do minus 3x4 minus 6x5. And 5, we know it's free because there's no pivot in this column. So x5 will equal x5. So from here, we set all these equations equal to 0, and we solve for each kind of... so for this first equation, we solve for x1. Since x2 is already x2, since it's free, we don't do anything with that. For x3, we solve for x3 after we set it equal to 0, so on and so forth. So a little arrow. So I'll go ahead and expedite this a little bit. x31 equals 2x2 minus 6x3 minus 3x4 minus 4x5. So this is this, and then the next thing we do to this is we divide this side by 3 to get x1 by itself, and then we'll get what x1 equals, but we'll do that in just a moment after we write everything else out. So x2, we don't do anything with it. Minus 14 x3 equals 5x4 plus 5x5. And then for x4, minus 3x4 equals positive 6x5. And x5 is x5 still, we don't do anything with that. Going to solve for these. Oh, I went run out of room. It's terribly inconvenient. Pain. So x1 will equal 2 over 3 x2. Oh Lord, please bear with me as I write all these tiny letters out. Then we do minus 6 divided by 3 will be minus 2. So minus 2x3. And then minus 3 divided by 3 is minus x4. We can just kind of erase the 1, so we can just kind of assume that it's there. And then minus 4 divided by 3 equals minus 4 over 3 x5. x2 equals x2. And then x3 equals 5, minus 5 divided by 14. So we're just going to divide this side by minus 14. x4 minus 5 divided by 14 again. x5 and x4. We'll divide everything by minus 3, so it'll be minus 2. x5 would be 6 divided by negative 3, minus 2. And x5 equals x5. So now that we have each variable solved for, we can scroll down a bit here. We're going to continue this. So we write, so the basis of the null space of A equals, so after this equals, we'll do this little thing. So now we take all the free variables, sorry. So the free variables are x2 and x5. So for x2, so in terms of x2, we now list how many times x2 is in each of these equations. So for the first row, x1 equals 2 over 3 x2. So for row 1 will be 2 over 3, since x2 is used 2/3 times in the first row. x2, there's one x2 in this row, so we'll do 1. There's no x2s in the equation to solve for x3, so we'll do 0. Same for x4, be 0. And same for x5, be 0. So that's halfway done. We'll do a comma. And then in terms of x5, since that's our second free variable, how many times is it in the first row? It'll be minus 4 over 3. In the second row, it'll be 0. The third row would be minus 5 over 14. Minus 5 over 14. And then in the fourth row, it would be minus 2. In the fifth row, we have 1 x5. So this is the basis of the null space for matrix A, which is right here. We have the basis of the column space right here. So we can go into 2.9 a little bit here. So the rank so in my words, the rank is the amount of free variables. It's kind of in layman's terms. So it'd be 3. So rank equals 3. Then the nullity equals 2, since we have 2 free variables. So the rank plus nullity theorem, which will be 2 plus 3 equals 5. And we have 5 variables. So we know that this checks out. So these are all the sections that I've had difficulty with. and a few examples of each, or